Intensive and extensive properties. This is probably new. You have probably never heard these words before, at least not in this context. So let's talk about it. Intensive properties are independent of the amount of substance you have. That's how you're going to remember this, by the way. Intensive is independent of the amount of substance that you have, meaning the amount of stuff does not matter. These properties cannot be added together. For example, color is an intensive property, meaning like this pen is gray, and it doesn't matter if I have the one pen or if I have 30 identical pens, no matter how many of them I have, is a great pen. The color is an intensive property because it does not change no matter how many of these I have. The amount of stuff does not matter. And I cannot add color together as a property. Like if I say I have 30 of these pens and they're gray plus gray plus gray plus gray, that doesn't mean anything. That's gibberish. So color is an intensive property. Another intensive property is temperature. If I have this cup of water, quart of water, and I take the temperature of this water, this is going to be roughly room temperature because I've been sitting here recording videos for a while. It's a little peek behind the curtain for you. I've been doing this all on the same day. That's why all these videos are me in this one t-shirt. Anyway, this is roughly room temperature water. So like 25 degrees Celsius. And if I pour half of this into another cup, that's still going to be room temperature 25 degrees Celsius water. No matter if I have the whole quart or if I have a pint, half a quart is a pint, right? If I have a pint in two different cups, it's still going to be the same temperature. It doesn't matter how much of it I have. That doesn't change the temperature. And additionally, you cannot add temperatures together. Like if I had half of this and another cup with the other half, I said, this is 25 degrees Celsius and this is 25 degrees Celsius. So the total temperature is 50 degrees Celsius. That's gibberish. Temperature doesn't work that way because temperature is an intensive property. And then density is an intensive property, meaning that the density of something does not change, no matter how much of it you have. If I have a gold bar, like in old Western movies where there's always like a cowboy either stealing or protecting, it can go either way, but like those like bars of gold, you know what I'm talking about, like from movies, those bars of gold. It doesn't matter if I have one whole bar of gold or if I just like chip a little bit off and take like a little speck of gold. The gold is going to have the same density because the ratio of its mass to its volume, right? That's what density is its mass divided by volume. That ratio is going to be the same because even if I get a smaller piece that weighs less, it also takes up less space. So the ratio is going to end up coming the same, coming out the same when you divide it, even though the piece is a different size. If the amount of stuff does not matter, that tells me density is an intensive property. Let's talk extensive properties. Extensive properties are dependent on the amount of substance that you have. The amount of stuff does matter. These properties can be added together. Surprise, intensive and extensive are opposites. For example, length, mass, and volume. I can measure length and how much stuff I have will change the length. If I have more stuff, it's going to be longer, right? Like here's my yoga mat. Okay. And I can like take a ruler and measure how long this is. But if I also pull out my toddler's yoga mat, when I have more yoga mat, it's going to be longer, right? Like this length by itself versus this length of everything. That's different. When I have more yoga mats, I have more length. Because the amount of stuff changes the length, that tells me that length is an extensive property. The amount of stuff does matter. And these properties can be added together. I could separately measure this length, get a ruler, separately measure this. I can add those two lengths together. The two numbers I get, I can add those together and I'm going to get the same total length. That makes sense because that is how length works. Because length is an extensive property, and that's how extensive properties work. Mass. Similarly, I can see that mass is dependent on how much stuff I have. So if I have more stuff, it's gonna weigh more, right? Like, again, I mentioned on another video, or maybe it was earlier on this video, time is meaningless. I don't really know anymore. But anyway, if I'm baking, right? Sometimes I bake and I use British recipes, and instead of like using measuring cups, a lot of British recipes make you weigh everything. So like if it tells me I need 250 grams of flour to make this loaf of bread, or if it tells me I need 500 grams of flour to make this loaf of bread, that's going to take up different amounts of space because it's going to be like 250 grams is less stuff and 500 grams is more stuff. And I might need a bigger bowl if I'm using a recipe that says 500 grams of flour. The amount of stuff you have matters, but you can also add it together. Like I could weigh out 250 grams, put it in a bowl, weigh out another 250 grams, add it together. There's my 500 grams. The amount of stuff matters because if you have more stuff, you have more mass. You can add masses together. Those are the two things that tell you mass is an extensive property. Volume works similarly. Going back to my big old cup. This cup has a 1 quart volume. And if I fill it all the way to the top, then this is 1 quart of water. If I get a second cup full of water, now it's 2 quarts of water. I have more water and that changes the volume. That's different from intensive properties, right? Like if I had 2 cups and I filled them with, I don't know, like purple Kool-Aid, right? Like having 2 cups full of purple Kool-Aid, the color is going to be purple no matter how many cups of Kool-Aid I have. Because color is an intensive property. It does not matter how much you have. But volume is extensive. If I have 2 cups, then I'm going to have more stuff and more volume. That's what an extensive property is. So let's think about like if I have 2 cups of water. Here's a big cup of water. Okay, and I'm gonna have 2 empty cups. I'm gonna take like half of the water that's in here. I'm gonna pour it into these cups. Does the total volume of water change when I pour half of it out? Like I had this water, I moved it into here. I've also got this water. Is there the same total amount of water? Yeah, that volume does not change. When you think about the total. But when you think about the individual pieces, then each cup has its own volume. But if you have more stuff, then you have more volume. That's what tells you volume's an extensive property. But if I take those 2 smaller cups that I poured half into. And then I measure the temperature, like stick a thermometer in there. Pretend that's what thermometers look like. Is the temperature going to be different? No. The temperature, like in the big cup, the temperature would be the same in all 3 cups. How much you have does not change what the temperature is. And that's what tells you temperature is an instance of property. So you can answer these two yourself. Yeah, that's intensive and extensive properties.